see the reciprocal of sine theta over r. Yeah. Okay, so so number 25 says what? Suppose that the cotangent at a certain time is twice the length of the radius. So now the cotangent is the shadow, right? So suppose that the shadow is equal to twice the gnomon. So suppose LK, the shadow, the cotangent at a certain time, is equal to 2 times the gnomon, which you could, you know, just write 2, I suppose, if you're accepting that the gnomon is length 1, right? Which I suppose we could do. You want to do that?
Yeah.
All right, let's just call that 2. Then what do they want us to do? Follow L by Rooney's directions to multiply the cotangent by its equal and take the square root of the sum of that with the gnomon. Okay, so the cotangent times its equal, that's just the square of the cotangent, right? The cotangent being the length of the direct shadow of the gnomon. So, and add to that, what does it say? Multiply the cotangent by its equal and take the square root of the sum of that with the square of the gnomon. Okay, so the sum of that, the square root of the sum, don't they say? Okay, sorry. The square root of the sum of that with the gnomon is LK squared plus EL squared and the square root of that, right? So that's going to be square root of 4 plus 1, which is going to be square root of 5. To obtain the cosecant. So we have the cosecant is, this is the cosecant here, right? As we saw, the cosecant is the hypotenuse of the direct shadow. Okay, so we're going to obtain the, yeah, so we know that the Pythagoras at work here, right? LK squared plus EL squared is EK squared. So the square root, so we're going to have EK is equal to the square root of 5. Then divide the product of the gnomon with the total sine by the cosecant. Okay, we're going to divide the product of the gnomon, which is EL, with the total sine, which is R, by this cosecant. Okay, so divide the product of the gnomon with the total sine by this, right, to get, what are we going to get? We're going to get the sine of the altitude. Okay, so the sine of the altitude, well, that's the sine of theta, and that's going to be the gnomon times the total sine, which is EL times R, divided by square root of 5. So we have sine of theta is equal to HT, and so if we take this as equal to, EL is equal to 1, right? So this is R over the square root of 5, and so we can think of that as square root of 5R over 5, right? Which is approximately, do we know the square root of 5 to 3 digits, let's say? About 2.236, that's 4 digits. Okay, so let's say that. So it's going to be about 2.236 r over 5, and we can convert that to decimal. Multiply the top and the bottom by 2, and you'll have 10 on the bottom. It's easy to divide by 10, right? So you'll have 0.4472 r. How are we doing here? There's a lot of instructions. We're trying to follow them, right? The result is the sine of the total. Now find its corresponding arc in the sine table. Okay. So what do we get here? We got the sine of theta is 0.4472. So we can go to our table and what are you going to get? An angle of about 26 degrees. A little bit more.
26.
Yeah. So this would be where you would look that up. So this implies that theta is about 26.
15.
How far off are we? Can we just call it 2630, something like that?
15, isn't it?
26.3. So 3/10 is how many minutes? 18. So it's going to be about 26 degrees in 18 minutes. Does that seem reasonable? All right, so if your shadow, I mean, this picture almost is like that, right? So if I find the length of the gnomon is 1, and I lay off 2 gnomons on my shadow, so that the shadow is twice the gnomon, then this angle is about 26 degrees, a little more. Oh, sorry, 18 minutes.
18 minutes.
Sorry. I don't know why I did that.
Awesome.
Does that agree with your understanding?
Yes.
Okay. So we go back to our document. So there comes, okay, there comes out the altitude of the sun at the time of that shadow. How high is the sun off the horizon at that time? Well, we're saying about 26 degrees or more. Questions about that? All right. So this is how trigonometry was built. 27. Refer to the final paragraph. If the altitude of the sun is known to be 37.5 degrees, use the table to find out the corresponding sine and cosine values. Then follow Alibi-Rooney's instructions to work out how many gnomon lengths the corresponding shadow of the sun would measure. Okay, so this is 26 now?
Oh.
Or 27, we did 26 somewhere in there.
we did 25.
Oh, did I skip 26? I did. Okay, I see 26. Translate the second paragraph in the last passage above into a formula relating cotangent theta and cosecant theta, adopting the convention the gnomon has unit length. Right, so that's what we've been doing. Second paragraph into a formula relating cotangent and cosecant. So how do we understand cotangent and cosecant to be related? Do we know a relationship between these? Cotangent is adjacent over opposite, and cosecant is hypotenuse over opposite, right?
So I think the way to think about it can we think of it the same way as sine with cosecant and just flip them? Is that correct? Because that's your reciprocal. So if we know sine and cosine and tangent, finding cotangent, cosecant, and secant should be just a matter of flipping them. Is that right?
Yeah, they're reciprocal functions, sure.
Okay.
So we have, this little thing going on here, right? So this is the cotangent down here. This is 1. relationship between these things. So what would you say is a relationship without reading the text? Oh, EL, like so, right? Well, you would say LK squared plus 1 squared is equal to EK squared, because that's Pythagoras' formula, right? So in other words, cosecant, or let's see, LK is the cotangent squared plus 1 is equal to cosecant squared. And ordinarily, I don't drop the argument for a true function, but it's understood that these all relate to this angle here, right? So it's just sort of understood that's the cotangent corresponding to a particular angle. All right, so here's our relationship. Part B, translate the third paragraph, and I don't know, did I translate